So we are looking at intra-seasonal timescale tropical extratropical interactions, but as we said in the beginning, the tropical extratropical interactions happen at low frequencies as well. So you have a low frequency phenomenon like El Nino, which sets up background conditions or changes in background conditions at a lower frequency on interannual timescale, and MJO acts at intra-seasonal timescales on top. So how they interact, especially when MJO is a moving heat source, and it can interact with the El Nino itself, and together they can create tropical extratropical interactions. The situation obviously becomes quite complicated. So these few slides show a good example of how that works. We'll focus on something called a blocking pattern, where in the mid-latitudes typically the confluence of mean flow and the waves end up producing something like a high pressure block. It's called blocking because the high pressure sits there for much longer than weather timescales, let's say a few weeks, so into the intraseasonal time scale, and it's such a high large scale of high pressure that it begins to steer flow around it. So it can steer Rossby waves around it, it can steer cold waves, heat waves, and so on. So obviously for lots of places like the European map in the background here, Scandinavian region, begins to experience, you can see that the winds are being steered from way lower latitudes up into this region and around, instead of going across here because of this blocking pattern, for example. And you can see it can obviously create anomalously warm temperatures, and of course it can also create anomalously cold temperatures depending on the season. So we have to basically now try to understand how MJOs can affect the blocking patterns, and there is clear evidence that based on the phase of the MJO, the blocking frequency can change, and it also depends on whether you are in the Atlantic sector, the Pacific sector, or the Eurasian landmass, and so on. So this is just an animation from this blog from NOAA, which is showing the MJOs here in different phases, looking at the maritime continent sector and the Atlantic sector, and it's also showing nicely the mid-latitude storm track here, which obviously is becoming stronger and weaker over phases of the MJO, which we talked about before in terms of the tropical extratropical connections. So this is where one window of extratropical influence into the tropics exists, and another window exists here, because these zonal jets are constantly producing breaking waves and energy that can then get shed into Rossby waves that make it into the tropics, and so on. So in the context of this El Nino and MJO together affecting mid-latitude weather, this is a nice metaphor provided by this blog, which says ENSO is like a big ship which generates this wake, which is like standing waves as far as MJOs are concerned, because it's a low frequency phenomenon which sets up low frequency waves. And MJO is, on the other hand, is like a speedboat which moves much faster than this big ship and can interact with the wake of the big ship and create atmospheric impacts like atmospheric rivers, heat waves, cold waves, and so on. So United States is sitting here and being vulnerable to the waves generated by a combination of this ENSO and MJO. So another way to look at it is that the El Nino generates low frequency envelope of rainfall anomalies, and MJO is riding on top, producing wavy patterns in rainfall. So depending on the ENSO and the MJO phase, you can have rainfall that is having either a constructive or destructive interference. So you can end up with extreme events that are either wet in terms of, let's say, snowstorms or rainstorms over California, or they can become become extremely dry as the heat dome and the extreme drought that's been going on in the California region shows. So this tells you that the MJO influence on the extratropics is not just a good example of tropical extratropical interactions, but it also makes life complicated by its dependence on El Nino and its destructive and constructive interference with El Nino. So to take this further, the blog provides MJO and ENSO influence on precipitation patterns with the combination of things. So when you have constructive interference of just phase 6 and 7 of MJO with La Nina, there is a reduction of this precipitation drought or dry anomaly. You can see that both these regions have been changed, and also some changes over here, which may be actually a bad influence, because La Nina typically produces drier climate, drier weather over here. So you can see that the MJO influence, which is positive here, has been negated by the La Nina, and when they are combined together, you have so La Nina produces this effect, MJO produces this effect in phase 6 and 7. When they are combined, you are having a wetter anomaly here, reduced wet anomaly here, and so I said that wrong. There is a dry anomaly produced by La Nina, a dry anomaly produced by MJO. They constructively interference to produce a much drier anomaly over here in the southeast US, extending all the way into the northeast. Okay. Similarly, when you look at destructive interference or cancellation, MJO in phase 8 and 1 in the western hemisphere, that is when MJO convection is in the western hemisphere, it's producing this very nice wet anomaly here, whereas La Nina produces a dry anomaly, and together the wet anomaly is weakened. Here dry anomaly is amplified, and here wet anomaly is weakened by the phases. So another example of how ENSO, MJO and tropical extratropical connections work. So here is the example of blocking high pressure, which is going to create variable jet stream. So it's going to allow the jet stream to dip going around the blocking pressure here and bring down cold Arctic air behind it, which is going to meet the subtropical relatively warmer airs and create wetter conditions here, whereas drier and warmer conditions over this large region, and wetter conditions just to the north of it. So this is the wintertime La Nina pattern on which the MJO can do constructive or destructive interference. Okay. This is another paper which looked at warm ENSO and various phases of MJO. So here is phase 3 and phase 7, and this is cold ENSO, so La Nina. So this is El Nino, this is La Nina, and this is again looking at phase 3 and phase 7, phase 3 and phase 7, and it is looking at the change in the frequency of a blocking pattern. So in phase 3 you have interference with ENSO, which reduces the frequency of blocking, whereas in phase 7 El Nino and MJO together produce increased frequency of blocking in terms of percentages shown here. Similarly, during La Nina phase 3 you have a great reduction in the frequency of blocking, whereas the phase 7, the increase is not there, as you saw in the superposition of MJO phase 7 with El Nino. So El Nino and La Nina have asymmetric impacts or opposite impacts in some ways. El Nino doesn't do anything here with phase 3 of MJO, but increases the blocking frequency quite a bit over here, whereas La Nina decreases the frequency over here in phase 3, but doesn't do much in phase 7. So again, just adds to the details of how tropical extratropical interactions are going to interact with the low frequency mode. So intra-seasonal timescale interactions are going to be modulated by interannual background state set up by El Nino and La Nina. Okay, so all these are relevant because they can add to predictability. If El Nino is predicted and MJO is predicted, then these blocking patterns and associated weather impacts can be predicted with more skill, and that's why you want to understand these, other than of course understanding the processes of how tropical extratropical interactions work at interseasonal timescales.